Hello everyone, welcome back to Gradeup. My name is Manshu Mittal and we have till now studied the probability. All concepts of probability we have studied till now. Now we will see the previous year questions of GATE examination that are asked in various branches. So let's start with the first question. So the first question is from GATE 2017 Mechanical Engineering. Question is a six-phase fair dice is rolled a large number of times. The mean value of the outcomes is. Question number 1. A dice is rolled infinite number of times, means a large number of times. Okay. Now we have to find the mean of those outcomes. So x is the outcome. X is a random variable which is giving us outcome, and what is the probability of getting that outcome that we have to find. So x is, this is a dice. Okay, now this is rolled, so we can get 1, 2, 3, 4, 5 and 6. So there are total 6 outcomes from a dice. And what is the probability of getting all these outcomes? It is 1 by 6, 1 by 6, 1 by 6. All the probabilities is 1 by 6. Why? Because in the question it is given that this is a fair dice. So fair means all the probabilities will be 1 by 6. Now what is the formula for the mean? Formula for the mean of a discrete distribution function. This is a discrete function. I told you why this is a discrete distribution function. And this is a general discrete function, neither binomial, neither Poisson. So the formula is sigma x px. So x is 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. This is the value. Now sum of all this is 1 plus 2. Sum of numerator is 1 plus 2, 3 plus 3, 6 plus 4, 10 plus 15, 21. So this is 21 divided by 6. This is the mean value, or we can write it as 7 by 2, or this is equal to 3.5. So the question is asking for the mean value of the outcomes. So the mean value of the outcomes will be 3.5. This is our answer. Okay, all of you got it? It's a very simple question. Just we have to apply the formula for the mean. Okay, see the second question. Second question is from 2017 Computer Science Engineering. Question is, if a random variable x has a Poisson distribution with mean 5, then the expectation of ex plus 2 whole square equals. Poisson distribution is given. So what are the properties of Poisson distribution? First we will see them. What are the properties? Properties are ex, mean of a Poisson distribution, is equal to lambda, and variance of a Poisson distribution is also equal to lambda. This is known to us because this is a Poisson distribution. Now if a random variable x is a random variable which has a Poisson distribution with mean 5, so lambda is equal to 5. Okay, we have to find the expectation of ex plus 2 whole square. Ex plus 2 whole square we have to find. If we expand this, we get ex square plus 4x plus 4. This is the mean. Now this is also equal to, since this is ea plus b plus c, this can also be written as ex square plus e4x plus e4. Now one thing you have to remember is mean of a constant is always equal to 0. So this is 0, mean of a constant. And ex square is like suppose mean is given here 5. So ex square, variance is ex square minus ex whole square. This is known. Since Vx is lambda and Ex square is not known to us, while Ex is known, that is lambda. So Ex square from this function is lambda square plus lambda. Okay, now putting the value, we get Ex plus 2 whole square. Ex plus 2 whole square is equal to Ex square. Ex square is lambda square plus lambda. Now E4x. E4x is, if a constant is multiplied with a random variable, then this constant can also come in the outside, means outside the mean value. So this is 4 into Ex. What is Ex? Ex is given to us as 5. So 4 into 5. So lambda is 5. So 25 plus 5 plus 20. This is equal to 50. So the value of this function is 50. Clear to everyone? So what properties we have used in this question? First property is, if a constant is multiplied with random variable and we have to find the mean, then this constant can come outside the mean. And second property is, the mean of a constant is always equal to 0. And the properties of Poisson distribution I have already told you in the previous lectures. Let's see the third question. Third question is, a person decides to toss a fair coin repeatedly until he gets a head. So a person is throwing a coin until he gets a head, only till then. He will make at most 3 tosses. So he is making only 3 tosses. After that he is not trying. So there are only 3 tosses, 1, 2 and 3. Okay. Let the random variable y denote the number of heads. So y is a random variable which is denoting the number of heads. What is the value of the variance of y? Equals. So we have to find the variance of random variable y, where y is known as, y is the random variable which is representing the number of heads. Okay. So y is equal to 1 and probability of y is equal to, suppose he tosses the coin and he gets the head in the first attempt only, then what is the probability of that? That is 1 by 2 in the first toss. That is the probability of getting head is 1 by 2. Now on the first toss, if he gets a tail, then again he has to toss. For that probability will be 1 by 2 into 1 by 2. On the second toss he gets head, but on the first toss he gets tail. This is the probability. And what about the number of heads? Number of heads is again 1, because in the first toss we get tail and the second toss we get head. So this is h, this is th. Y is representing number of heads, so number of heads are 1 only. If the next toss happens, then tth. In the first toss he gets tail, in second even he gets tail, and in the third toss he gets head. So this is 1 again. Head is, number of heads is 1, and what is the probability? 1 by 2 into 1 by 2 into 1 by 2. After that he is not making a toss if he doesn't get the head. Suppose he gets ttt, all tail, then number of heads are 0, and probability of this is 1 by 2 into 1 by 2 into 1 by 2. Probability of getting ttt is this. Now he is asking for the variance of this random variable. Y is known, py is known. Simply we have to do calculation. So ey, first we have to find the mean for finding the variance. Ey is y into py. So sigma y into py is equal to 1 into 1 by 2 plus 1 into 1 by 2 into 1 by 2 plus 1 into 1 by 2 into 1 by 2 into 1 by 2 plus 0. 0 is multiplied with this, we get 0. This is 1 by 2 plus 1 by 4 plus 1 by 8, and this is also equal to 8 into 4 plus 2 plus 1, or also equal to 7 by 8. So mean of this random variable y is 7 by 8. Now ey square is equal to sigma y square into py. Sigma y square. So y square is 1 square into py is 1 by 2 plus 1 square into 1 by 2 into 1 by 2 plus 1 square into 1 by 2 into 1 by 2 into 1 by 2 plus 0 square, or we can write it as 0 only. Okay, this is same as the mean. Why? Because 1 is squared is 1 only, and the expression is same, so we get 7 by 8. Ey square is also 7 by 8. What is the variance? Variance formula is Ey square minus Ey whole square. So 7 by 8 whole square minus 7 by 8. Okay, so this is 49 minus 7. 49 minus 7 is 42 divided by 64, or this is equal to 21 by 32. So let's see which is the option. None. Why? Sorry, I did one mistake in calculation. 49 minus, this is 49 by 64, while this is 49 minus 7 into 8, 56. Formula of variance is this, and we get 7 by 8 minus 7 by 8 whole square. So this is 47 into 8 is 56 by 64 minus 49 by 64, or this is equal to 7 by 64. So 7 by 64 is the answer. Option number C is the correct answer. So in examination you also have to take out the calculation error, means you don't have to do calculation error like I did here. Okay, so the answer is 7 by 64. Question number 4. Question number 4 is two players A and B alternately keep rolling a fair dice. Okay, the person who gets a 6 first wins the game. So two players A and B, suppose Ram and Sham are playing, and if anyone gets the 6 first, then he wins the game. This is the game. Now player A starts the game first. Player A is starting the game. Game starts. Okay. What is the probability that A wins the game? We have to find the probability of A winning the game. Okay. So what is the probability of A winning the game? This we have to find. Suppose in the first toss he gets the 6, then probability is 1 by 6, because he has to get the 6 in the first attempt. The probability is 1 by 6. If he doesn't get the 6 in first attempt, that means the probability of him not getting 6 is 5 by 6. Also B should not get the, means after that B will roll the dice, B should also not get the 6, because if B gets the 6, then the game gets over and B wins the game. But we have to find the probability of A winning, so B should also get number other than 6, and A gets 1 by 6. A gets 6 in the next attempt. So for second attempt, this is the probability. For third attempt, probability will be A loses, B loses, again A loses, again B loses, and then A wins. So this is 5 by 6 into 5 by 6 into 5 by 6 into 5 by 6 into 1 by 6, and so on. Okay, is it clear? Is it clear to you? So if I take 1 by 6, this you can see as 1 by 6 common, 1 plus 5 by 6 whole square plus 5 by 6 to the power 4 plus dash dash dash. Now this is a GP, and what is the formula for GP? Sum of the GP is A divided by, A is 1 by 6 is common, so A is 1 divided by, since it is a R is less than 1, R is equal to 5 by 6 whole square, R is less than 1, so the formula for sum of GP is A divided by 1 minus R. 1 minus R is 5 by 6 whole square. 5 by 6 whole square is 25 by 36. So this is 1 by 6 into 36 divided by 11, or 6 by 11. So probability of A winning the game is 6 by 11. So in this question GP is also used. So you have seen how to we get the answer. So many questions are asked in the GATE examination based on this formula only, means of GP. So everyone clear? If you have any doubts, then you can ask in the Q&A section. Let's see question number 5. Question number 5 is asked from 2016 EC Electronics Set 1. Question is, two random variables x and y are distributed according to fxy is equal to x plus y, and x is between 0 to 1 and y is also between 0 to 1. Okay. Now, and second thing also given 0 otherwise. otherwise it is 0. Okay, this is the probability distribution function given to us. What is the question? Question is, what is the probability of P x plus y is less than or equal to 1 is? This we have to find. How do we find now? Let's see. To find the probability, we know formula: integration from minus infinite to infinite fx y minus infinite to x, this is px, fx y dx. This is the probability of x is less than or equal to x. But what we have to find? We have to find x plus y is less than or equal to 1. So replace x with 1 minus y. So probability of x is less than or equal to, y gets on the right hand side, we get x is less than or equal to 1 minus y. So x is less than or equal to 1 minus y. This probability we have to find. So this will be equal to limits from minus infinite to 1 minus y fx y x comma y dx dy. Here also dx dy. Since it is a variable on two variables, since it is a function of two variables, that's why double integration dx dy. What about the limits on x? See, limits on x are given in the question only. Limits are 0 to 1. So limits on x are from 0 to 1 and limits on y are also from 0 to 1. So here we have put the limits for x. X is from less than or equal to 1 minus y. So that here we have put the limits from minus infinite to 1 minus y. What about the limits of y? Limits of y will be from 0 to 1. Now integrate this function. We get the desired probability. Okay, how to find? X plus y dx dy integrating from minus infinite to 1 minus y and 0 to 1. It is also given that y can't be less than 0. Y is always greater than 0. So here limits will not be from minus infinite. This will be from 0 to 1 minus y. You all got it? Why I write 0 here? Okay. So x plus y integration of with respect to x dx, we get x square divided by 2 plus xy dy. Integration from 0 to 1 minus y, and here integration from 0 to 1. No, we have to put the limits now. 0 to 1 minus y. 0 to 1 minus y. Putting the limits, we get 1 minus y whole square divided by 2 plus 1 minus y into y minus 0 minus 0, and integrating whole function with respect to dy, limits from 0 to 1. Let's solve the question here. So 1 minus y whole square is 1 plus y square minus 2y divided by 2 plus 1 minus y dy, limits from 0 to 1, is equal to 1 plus y square minus 2y plus 2, I am taking LCM here, plus 2 minus 2y divided by 2. Now this is simple calculation only. The main point of concept was till here only, till where we have to put the limits. After that this is simple integration solving. Till here we have to apply the concepts of probability. In limit integrating from 0 to 1, we get y square minus 4y plus 3. Y square minus 4y. Sorry, I did one mistake. I forgot to put y here. So this is 1 minus y into y. So this is 2y minus 2y square. So this will be 2y gets cancelled with 2y. This is 1 minus y square divided by 2 dy. Now I am integrating with respect to y. This will be y divided by 2 minus y cube divided by 6. Putting limits from 0 to 1, we get 1 by 2 minus 1 by 6, or this is equal to 1 by 3, or we can also write it as 0.333. So option number A is 0.333, and that is the correct answer. Okay, you can pause the video and check how I have done all these calculations clearly. Okay, let's see the sixth question. This is a very important question asked in the GATE examination only once. So this was the toughest question from probability till now from my point of view. Let's see the question. Question was asked in electronics in 2015 set 2. Question is, let the random variable x represent the number of times a fair coin needs to be tossed till 2 consecutive heads appear for the first time. Till 2 consecutive heads HH appears for the first time. We are means throwing the coin around n number of times until we get HH in a consecutive manner. What is the expectation of x? We have to find the expectation of x. You think this is a very simple question, you can solve easily, but if you try to solve this question, you will get so many doubts. Let's see what's my way of solving this question. What is the probability of getting first head? If we have to find if we have to find the probability of 2 heads, first we should get 1 head only, then only we can get the second head. Until we get t, there is no way we can find directly 2 heads. So for getting 2 heads consecutively, we should get first head. And what is the expectation of finding first head? Let's see that first. So what is the expectation of finding first head is x and px. Okay, let x, suppose I am taking y, x is given in the question, so I am taking y. Y is a random variable which is representing the probability of getting head. So suppose in the number of attempts, in the n number of attempts, y is the number of attempts in which we get the first head. So suppose this is 1, so probability is 1 by 2. Probability of getting head in the first attempt is 1 by 2. Probability of getting head in second attempt is 1 by 2 into 1 by 2. Probability of getting head in third attempt is 1 by 2 into 1 by 2 into 1 by 2, and so on. Now what is the mean? What is the mean of this random variable y? This is sigma y into py, or 1 into 1 by 2 plus 2 into 1 by 2 into 1 by 2 plus 3 into 1 by 2 into 1 by 2, or I can write this as 1 by 4. Let's write it directly 1 by 4. Let's write it directly 1 by 8. Let's write it 4 into 1 by 16, and so on. This will be the EY. Now to find this sum, we have to multiply with half on both sides. We get half into 2 is, half into 1 by 2 is 1 by 4. Let's write it from here 1 by 4, plus 2 by 4 into 1 by 2 is 2 by 8, 2 into 1 by 8, plus 3 into 1 by 16, plus so on. Now let's subtract EY from EY minus 1 by 2 EY. So this will be 1 by 2 EY is equal to 1 into 1 by 2 plus 2 minus 1 into 1 by 4. So 2 minus 1 is 1 into 1 by 4 plus 3 minus 2 into 1 by 8. So this is again 1 into 1 by 8 plus 1 into 1 by 16, and so on. The sum, this is a GP of R is equal to 1 by 2 and A is equal to 1 by 2. So this is 1 by 2 divided by 1 minus 1 by 2, or 1 by 2 divided by 1 by 2 is equal to 1. So EY is equal to 2. the mean of getting the head in the mean of getting first head is 2 only. Now we will see how to get the 2 consecutive heads. Now listen to me very carefully. Suppose the mean expectation of getting 2 heads consecutively is Ex. This is, I am letting, this is Ex. Now this will be equal to, first we should get one head. For getting one head, we know expectation is Ey. Till just now we have find the Ey is equal to 2. For getting second head, there are 2 probabilities. Either we can get head or we can get tail. Suppose we get tail. If we get tail, then again we have to get again we have to get the first head. For getting first head, the probability, the mean is Ey plus 1. Why 1? Because in finding the for getting the tail again, this is H, again we are getting T. So one attempt is gone in getting this T. So 1 is added, plus Ey is the number of tosses again. Suppose this is HH. So Ey plus 1, and there is also 1 by 2. And if we get head in the next attempt, we get the head here and again we get here. So this is only one attempt more. This will be the total Ex. Okay, so Ex will be Ey. Sorry, one mistake I did. This should be Ex. Why Ex? Because if we get T here, then again we have to get the 2 heads. For getting 2 heads, we let the probability, let the mean should be equal to Ex. So this will be Ex. So Ey is given as 2 plus 1 by 2 into Ex plus 1 by 2, and this is equal to Ex. Now let's solve this linear algebraic equation. We get 2 plus 1, letting LCM as 2, this will be 4 plus Ex plus 1 plus 1. 2 will be multiplied here, we get 2 Ex is equal to 6 plus Ex, or Ex is equal to 6. So the mean is equal to 6. Even in the gate problem, means the question that is given by the gate authority is 1.5, and that is the wrong answer. Why? Because for getting only first head, we have found the probability to be, we have found the mean to be 2. So how it could be 1 less than the probability of getting one head only? So it is not possible. The correct answer is 6. Okay. So just check how I have solved this whole concept. This is the toughest question till now asked in the gate examination from probability part. Okay. So in the next lecture, we will see the numerical methods and differential equations. First we will see differential equations, then there will be lecture on the numerical methods. So thank you very much.